One very important tool for engineers or aspiring engineers is Excel, which allows you to simply and quickly generate graphs and perform complicated calculations in a methodical and WYSIWYG, or what you see is what you get kind of way. It is important to remember that Excel and all other programs are tools that allow you to program a process that you have already defined clearly for yourself. For example, if the problem is to graph a cosine function, you need to fully understand all the properties of the cosine function. Here I have written the cosine function with all the parameters that characterize its behavior. A is the the magnitude, F is the frequency, and phi naught is the initial phase. There is a second format for writing the same function, which uses omega as a parameter. The frequency, or F, is measured in hertz or cycles per second, while omega is measured in rads per second. The distinction between F and omega will become clear as we talk later about the nature of this function. So let's first discuss this relationship. In order to do this, I'm going to draw a unit circle with the radii drawn at 1 radian intervals. Omega is the radian frequency and expresses how many radians a vector would rotate in 1 second. Frequency is measured in hertz or cycles per second and expresses how many full circles a vector will rotate in 1 second. Since 1 full circle is 2 pi radians, omega is equal to 2 pi times F. So why do I keep on talking about a rotating radius? You see here a circle drawn on an xy plane with a radius drawn in red. The radius's initial position is at phi naught equals 0. To the right of the circle, I have drawn a graph of time versus the projection on the y-axis of the point at which the radius intersects the circle as it rotates around it at a constant angular velocity. On the bottom of the graph, I have placed the projection on the x-axis of the point at which the radius intersects the circle as it rotates around the circle at a constant angular velocity. As the radius moves around the circle, I take its projection on y and x and plot it against time in the corresponding graph. The frequency f corresponds to how many full circles a radius can make in 1 second, while the radian frequency corresponds to how many radians it completes as it rotates at a steady rate around the circle. So you see now how we create the cosine function and the sine function from the projection of a rotating radius as it rotates around the circle with at a constant velocity. Now that you understand the cosine a little better, let's see how to plot it. You open an Excel file and choose Blank Workbook. In the box corresponding to column A, row 1, fill in the number 0. So make sure in the box that gets generated that you choose columns and fill in the stop value. You should get a list of numbers from 1 to 6 with a step size of 1. Now go to E1 and enter mag, and underneath that 10. If you then go to the Formulas tab, so you have to go all the way up here and choose the Formulas tab, and then Create from Selection. This actually creates a parameter, and you repeat the same process for the parameter FREQ. Now in B1, you type in the equation for the cosine function with mag as a magnitude, and you will see now that now B1 is now populated by the value 10, which is actually the calculated value of your cosine function at time t equals 0. If you now select the box B1, so you're select. So let's try now to use a step size equal to 0.5. You do have to remember to set your problem up again. Remember that you have to switch from rows to columns. Let's see how to plot this before we go any further. I choose my A and B column. I choose all of the all of these boxes by just selecting A and then dragging it out to this full range here. And then I want to go to Insert, and over here I can choose, I have a lot of options, and I can choose my chart type from this window here. I'm choosing Scatter, and then I'm choosing this time you're setting up a step size of, you end up so how do I work with the axes? If I go to chart design, you also have the option when you go, I chose one of those types, you do